Solving absolute value inequalities. An absolute value inequality is going to have this form to it. If it has a less than inequality, it will look something like this. If it has a greater than in it, it will look something like this. We're sticking with only solving linear absolute value inequalities in this section. When it's set up like this, our k is going to be a non-negative number. In order to solve our absolute value inequalities, what we have to do is we have to take it from this form and rewrite it as this, or this form and rewrite it as this. So these two statements here, you will be referring to quite a bit. You will need to know how to rewrite your inequality statement. So let's take a look at a couple of problems. Here we have solve each equation. We have the absolute value of 2x minus 5 is less than 4. So this is one that involves the less than. So our statement said that if it's in this form, we're going to rewrite it as the opposite of k. Whatever number is over here, we rewrite it as the opposite of that, is less than. Now I'm going to use less than or equal to because my problem has the equal part with it. Then I bring the 2x minus 5. I don't change anything here. I just put it right here. That's the ax plus b part. Will be less than or equal to that k again. So this is negative 4 is less than or equal to the 2x minus 5 is less than or equal to positive 4. And what we saw with solving compound inequality statements like this is we solve it by getting the x by itself in the middle. So what I need to do here is add 5 to all three portions of my compound inequality. This gives me a positive 1 is less than or equal to 2x is less than or equal to 9. Now to get the x by itself in the middle, I need to divide all of this by 2. So I end up with 1/2 is less than or equal to x is less than or equal to 9/2. So this is in interval notation. It would begin at 1/2 and it would end at 9/2, and we would use a bracket at each end value because we have the equal portions. If we were to shade on the number line, if this is my 0, it would go from the 1/2 up to 9/2. It would include all of this portion in between these two numbers. This problem is a greater than statement. So here we will follow what the other slide had about the greater than some constant number. Here we actually have to convert it into two separate inequalities. If the absolute value has to be greater than 20, then we know this thing has to be more than 20 units away from 0. So we could get more than 20 units away from 0 by going left more than 20, which means we would be less than negative 20. So this would be negative 3x minus 7 is less than negative 20. Or we could go more than 20 units in the positive direction. So that means greater than 20. So we'd have negative 3x minus 7 is greater than positive 20. And we would have to solve both of these inequalities. So I'll add 7 to both sides. That will give me negative 3x is less than negative 13, which gives me negative, let's see, when I divide by negative 3, it gives me x is greater than 13/3. Remember, when you divide by a negative number, you have to reverse the direction of the inequality symbol. Now on this one, I solve it using basically the same steps. I add the 7 to both sides. That gives me negative 3x is greater than 27. Then I divide by negative 3. And once again, because I divided by negative 3, I have to reverse the direction of my inequality symbol. So here what I have is, if we think about our number line, my negative 9 is down here. 13/3 is up here. 13/3 is actually 4 1/3. I want to shade numbers greater than 13/3. So that's going to be from 13/3 to the right. So that's numbers at the right end of the number line. The x is less than negative 9 are numbers that are to the left of negative 9. So here I have the two separate regions. So you have to have an OR statement in there, or an interval notation. It would be negative infinity to negative 9, union 13/3 to positive infinity. Now let's look at one more, and I want to look at the graph of this one. We'll solve it using the same method we just did. We'll take what we know is equivalent. Here we use the formula that the absolute value of ax plus b is less than k. We rewrite as, a negative k is less than the ax plus b is less than the positive k. So here we have a negative 15 is less than negative 2x plus 5 is less than a positive 15. Now I solve this by getting my x by itself in the middle. So I have to subtract 5 from all three parts of this compound inequality. So this will give me negative 20 equals negative 2, is less than negative 2x is less than 10. Now I need to divide everything by negative 2. So negative 20 divided by negative 2 is 10. When I divide by a negative, I reverse the direction of my inequality symbol. So I have is greater than x, and now I reverse the direction of this inequality symbol to have is greater than a negative 5. So here, what I really have on my number line is, here's my 0, here's my negative 5, and here's my 10. The x is less than 10, and the x is bigger than negative 5. So here I actually have points between negative 5 and positive 10. And it would stop at each endpoint. So interval notation would be negative 5 to positive 10, using a parentheses on both ends. Now I want you to see this on the calculator. I want to solve this graphically. So let's go to our y equals screen. Let me see, I can't get my calculator. Let me reset it. Now I can go there. And y1, I want to use the absolute value, so I go to Math, then I arrow over to the num column, and I pick the first option. So I want the absolute value of negative 2x plus 5 in y1, and I want the 15 in y2. Now I need to set my window so that I can see that. Here, my standard window only goes up to a y value of 10. I need the y value to be bigger than that 15. So I'm going to go up to a y value of 20. So I've set my y max to 20. The absolute value graph is the V-shaped graph. And here is the line y equals 15. Y equals 15. So I can see that this is intersecting at two different points. So I want to find those points of intersection. To find the first point of intersection, I move my cursor over to the first point and press enter 3 times. And there's my negative 5, x equals negative 5. I'll do the same thing to calculate the second intersection. I move my cursor over, only on the side-to-side arrows. It takes it a little while to get over there on this one. As long as I'm close, enter, enter, enter. And here's my x equals 10. I want to know where my absolute value graph, which is the V graph, is less than 15. So where it's less than 15 are the x values that are between this point and this point. So that would be between the x values of negative 5 and positive 10, which is what we have down here.